Hello dear friends, welcome back to my channel. I'm Gerard and I'm here to revise my trigonometric functions. But not only that, I want to know how to differentiate trigonometric functions. So by trigonometric functions, we're talking about sinus x, cosinus x, and tangent x. And when we are talking about trigonometric functions, we assume that the angle is in radian. And what's radian? So it's if we have a circle and the radius is 1, and we know that the circumference is 2 pi r for a circle, and if r is 1, so we have 2r. So the circumference, if we had to cut it here, it will be a line, and from here to here it's going to be 2 pi radian. And if this is 1, this is 1 radian. 1 radian is this 1 and 1 here. This is 1 radian. Okay, that was a definition. So now consider y is equal to sine x. So this is very simple, where x is measured in radians. So we know how it looks. It looks like this. This is 1 and this is minus 1. This is sine x. Yeah. Here we have y, here we have x. And consider this. So we say dx, which is very small. Let dx be a small increase in dx, sorry. So let's say, so it should be like this, right? It should be like this. Actually, should do it with another color is better. So something like this. So we see that there is a change in delta, in x, sorry, by delta x. And let the dy be the corresponding small increase in dy. So by that, because this is going to be just the same, what do we see here is that maybe we can just draw it like maybe we can draw it before. I think that's going to be better. We have here, we had this, and let's say if we draw it before, it's going to reach before, so that's better, right? So what's more, so we will have a small increase. This is delta x, let's say, and y is increased also by this much at the beginning. This is delta y. Okay, and so then we have y is equal to sine x, and y plus delta y is equal to sine x plus delta x. Okay, that's what we have. And I think you know how to do with this. We know that sine a plus b is going to be sine a cos b, sorry, plus sine b cos a. So we should do the same thing here, and you're going to get y plus delta y is equal to sine x cos delta x plus sine delta x plus cos x. So that's what we get when we do this. And that's good. That's really good. And I'm looking at this. If I did it right. Yeah, it's right. So if if delta x tends to 0, it means that then cos delta x tends to 1. That's something we know. And sine delta x is going to be to 0. Actually, it is saying sine 0 is 0. It's not delta x, but here it's saying delta x. But then we can simplify this. So what I need to do is we're going to erase this to make some space, and let's write here. So what do we need here? So this is 1. This should be 1. So y plus delta y is equal to sine x. Yes. Plus sine delta x cos x. There is no plus here. Okay. So, but there was something else said, that here when delta x is going to 0, so it's going to be delta x here. Sine x is going to be delta x. This is something I don't understand, because why not 0? Why not 0? Why delta x? Probably because if it's very small, it's going to be the same. Yeah. Okay, it's going to be the same. Yeah. Okay. That's you know, certain things I still don't get it right away. So that's what we have here now. And so approximately, we're approximating here. What else do we have? So if we want to have, we can rewrite this. We have y plus delta y is approximately sine x plus delta x cos x, right? And we can say sine x plus delta y is approximately sine x plus delta x cos x. What have we done here? Yes, we have sine x here because y is equal to sine x. Y is equal to sine x. We just put it here. So this is y. Y is equal to sine x. Very strange for me to work like this. So the y is going to be dy or delta y is equal to approximately to be, let me erase this. So what is it going to be? It is going to be, therefore, because this will cancel each other, yeah, and we'll be left with this, and then it's going to be delta y cos x. No, delta y or delta x cos x. So if we can make dy by dx is approximately cos x then. So what we just did is we did the differentiation of y is equal to sine x. That's what we did. We did the dy by dx, we got cos x. So guys, if you have y is equal to sine x, dy by dx is equal to cos x. And we can use a similar proof to differentiate cos x. So it's going to be cos x, then y is equal to cos x. Let me write it. So y is equal to cos x, dy by dx is equal to minus sine x, and dy by dx of for example for tan x, if y is equal to tan x, so it's going to be sorry, it's going to be cos x over minus sine x, so which is minus cot x. We can write it like this. Mm. No, it's not this. For tan, it's going to be a quotient rule. It's going to be a quotient rule. So for tan, if we have y is equal to sine x over cos x, if we know the quotient rule is going to be cos x times cos x minus sine x times because it's wait, it's v times du by dx minus u times dv by dx divided by v square. So we have this u times minus sine x divided by cos square x. So this is cos x square minus sine x square. So we know it's 1. No, it's not 1 because we have minus here. If it would be plus, it's going to be 1. So, but from identities, we know that there is something quite similar. Actually, no, because here it's minus, it's plus. We have minus here. Minus is plus. So it's going to be 1. 1 over cos this, we know it's, no, it's sec square x. That's what it is. So if you differentiate tan, which is this is tan x, you get this. Okay, that was a revision of this. And so now let's do some example. If you have y is equal to cos 2x, dy by dx is going to be what? It's going to be minus sine 2x times 2. is equal to minus 2 sine 2x. And you have, this is A, this is B now. B, you have y is equal to 5 sine 3x squared. So dy by dx is going to be 5 outside, and then we just do sine is going to be cos. Differentiating sine, yeah, it's cos, right? Cos 3x squared, yes, and then with time 6x. So overall is 30x cos 3x to the square. So that's what we have. And that's done. And then we have y is equal to 7 tan 4x plus pi over 2. So what do we do with such thing? We put the constant outside. Dy by dx is equal to tan 4x plus of. So this is quite difficult to do with. I'm just going to say let u is equal to 4x plus times 2. And this is a constant, right? This is a constant. Du by dx is going to be 4, right? And then we have dy, we have, sorry, y is equal to 710x, 10u, sorry. Dy by du is going to be this. We have to differentiate this. Differentiating tan, you get sec square x. That's what I know. That's what I know. So it's going to be u here. So let's do some cleaning here. Yeah, we are going to do some cleaning here. So we need, let's overwrite on this. We need dy by dx. Dy by dx is going to be dy by du times du by dx. So what is dy by du? Dy by du is here. It's 7 sec square u time du by dx. Yeah, du by dx. So we're going to have du by dx is only 4. So we have 4 times 7 is going to be 28 sec square, and u is going to be replaced by 4x plus pi 2. So this is the final answer. Let's see if yes, it's good. So guys, let's do some dy by dx here. Y is equal to sine 5x. Dy by dx is going to be cos 5x time 5. So 5 cos fine x. That's the answer. And then I have y is equal to 6 tan x divided by 2. Dy by dx, simple 6. And then I have sec square x by 2. Right? Times half, which give us This is 3 sec square x over 2. I would like to see the result for this, so just wait a moment. This is 4.5, 4.5, 4.5. Let me see the time. 20 minutes. Okay, 20 minutes, 4.5. I have to go all the way down here. And 4.5. 11 here. You need to go 4.5. 4.5, 4.5. 4.6, 4.5. 5 cos and 3 6 x. Yes, it's good. It is good. It is good. So I'm going to. So this is what I need. And yes, and now let's go back where we were. I'm not sure where. Actually, it was 4 something. Yes, 4.5. 4.5. Here we are. Let's continue with some exercises. So y is equal to cos x plus 2x. So this is going to be dy by dx. It's going to be minus sine x plus 2x, right? And I don't think we have to expand this, but we do have to time 2x plus 2. So it's going to be minus 2x minus 2 times sine x2 plus 2x. I'm having a big doubt about this. So let's have a look at where is it? I just took the picture. I've just taken the picture and I can't find. Here it is, screenshot. All right, minus 2. Well, he just put the minus 2 outside and then x plus 1. So another way to write it, and then sine x. Yeah, it is good. It is good, so we are on the right track. So it looks like it's not so difficult after all. Let's do y is equal to 4 tan square x. Okay, we know how to differentiate tan x, which is sec square x, but tan square x, that's tan x square actually, right? Let's rewrite it then. So y, let me just use this. Y is equal to tan. It was not tan. It was 4 tan square x. We can write it as 4 tan. I think that's how we can rewrite this, and we can just differentiate dy by dx. Y by dx is equal to 4. This is outside, we don't have to deal with it. And then we differentiate what is inside, not inside, but we do chain rule. Sorry, we have 2 tan x times what is inside 6 square x. So it's going to be 8 sec x tan x. Let's have a look. 8 tan x squared. So the correct answer is the power is the at, at the end, but it's good. Well, let's do something else. If we have y is equal to sine x minus, it's very easy. It's going to be cos this minus 7 times 3x2. So it's going to be 3x2 cos x3 minus 7. And so what's the answer for this one? This is also good. Okay, this is also good. We need now to do some something more difficult. Yeah, we have y is equal to 5 times 4x. This is also simple. dy by dx is going to be 5 sec square x times 4 is going to be 20 sec square 4x. Yeah, it's yeah, it's easy peasy. And we have y is equal to cos 3x dy by dx is equal to, we put this outside first. Well, I could rewrite this, but we have 3 here. This one is a bit complicated. It's a bit complicated, so it means that yeah, how do we do this? We have dy by dx is going to be 3 cos square x, right? Time minus sine x. So it's going to be minus 3 sine x cos square x. Tell me I'm right, please. Yeah, it's good. Really, I was thinking that it was going to be very hard, but looks like it's not so hard after all. So here we just have a product. We know how it works. We have dy by dx is equal to u times dv by dx plus v times du by dx. Nothing difficult, you just have to do it like this. So dy by dx is going to be sine 2x time minus sine x plus v is cos x time du by dx is going to be cos 2x time 2. Don't forget the 2. So it's going to be minus sine x sine 2x. We cannot combine them, unfortunately, plus 2 cos x cos 2x. So, well, we can put either one at the front or at the end. It doesn't matter. And normally we put the positive at the front, and then we minus this. That's how it is written there. No big deal once again. And let's do something else. Let's do y is equal to x squared tan 3x. This is also the same thing. The y by the x is going to be x squared times sec square 3x times 3, right, plus tan 3x times 2x, which give us 3x squared sec square 3x plus 2x tan 3x. So this is the answer, and we're going to check it, and it says that we have some problem here. Do we can, yeah, well, it says that we have x in common, so we could put the x and have 3x sec square 3x plus 2 tan 3x, and that's how it's written in the book. Well, it's still good, and we have something else now. Y is equal to cos 2x divided by x. This is nothing new. This is also easy. We don't have much difficulties here. We have x squared times, we differentiate this, you get minus sine 2x here, plus 2, and you have to minus this by cos 2x time 2x, right, and all this divided by x to the power of 4. So if we are careful here, we'll have minus 2x, yes, minus 2x x sine 2x, yes, plus cos 2x, right, and all this divided by x this, and we can just put it free here and take this away, and let's check the answer in the book. So what do we have? We have yes, we have something similar, only that they preferred to put something like minus 2x sine 2x plus 2 cos 2x divided by it's going to be minus here. Oh, be careful, that's a trick, and x3. So we have then this. I don't know why they didn't put the 2 outside this time, but it's still good. The answer is still good, and we have now sine cube 3x cos x. So this is also a product rule, and we are going to do it. So sine cube 3x times minus sine x plus, we have cos x times 3 sine 2 3x times 3, and that gives us minus sine x sine cube 3x, yes, plus 6 sine 2 3x, yeah, cos x. So this is something that we might have here, and Since we have free sine 3x, we can put it outside. That's what they said. And hmm. Here we have a problem here. Houston, we have a problem here. But it's supposed to be 2, yes? It's supposed to be 2 here. No, it's 3. But here it's 2. And it has something completely... Did I go completely out of my mind? Or 3x? It says that it has cos somewhere. Yes, this is cos. This is cos. Yeah, man. Well, something to redo. Finally, something that is difficult. I don't see where I made a mistake. I I do agree that I made a mistake. So let's do the dy by dx. So we have sine x, sine 3x. It should be x here. Wasn't it? Sine. Okay, I got this written the wrong way. There is nothing here. So it's sine 3x times minus sine x plus cos x time what? 3 sine 3x. Yes. Time cos 3x time 3. Okay, guys, I think I saw my mistake. So it's minus sine x sine cube 3x plus here I have like 6 cos 3x sine 3x plus cos x. I understand now. So this is what we have in common. Really not. This is up here, there. This is 2, this is 3. So, but we can put 2 there outside. So let me try without cheating to rewrite this. Let me try to do it. And we have sine square 3x outside. So here we will have sine x. Sine 3x, right? Plus we have here cos x plus, is it plus? We should not have plus here. It's we should not have this. So I think we have 6 here, and we have cos 3x here, and we close the bracket. Let's see here. So sine 3x is outside. We have sine x. There was a sign minus here. It's still minus. Plus, the only thing is that I missed a 3 somewhere. I'm just going to do the second part. The second part is, there's a problem with the second part. The second part is cos x times 3 sine square 3x times cos 3x times 3. Right? So I see 3 here, I see 3 here. 3 times 3 is 9. Oh my god, here it is. So we just did it right. Okay, and y is equal to 4 times root square of x. dy by dx is going to be, this is outside, so we have sec square root of x times x minus half. I think that's how it is. We have 4 root of x sec. That's what I have. Hmm. 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 Of course, I forgot to do something. Or did I? For me, this looks good, except that I forgot to multiply by half. Yes, it's going to be 2 here. So then it's going to be 2. Yes, you see, in the end I made some mistakes because you have to be careful. You have to be very careful. So how to differentiate this? So the derivative of this, it's half x minus 1. This is how I lose some points sometimes, by doing some silly mistakes. But that was the last here, and I think that we've done a good job. And it's 1 o'clock. It's 10 past 1 o'clock. So I will do my homework now. I think I'm ready to try my homeworks, and we'll see the result. So thank you so much, and have a very nice evening. Have a nice weekend. Take care. Bye.